Thank you. All right, thank you. Okay, thank you. You have 1 minute. Thank you. You should, because the answers may not work. Thank you. Okay, thank you. That's it. Okay, thank you. That's right. Thank you. Got about 20, I'll give you about 20 seconds. 20 seconds. Okay, thank you. All right, is there anybody else? Anyone else need turn in still? Yes? Okay, thank you. All right, anybody else? All right, what was the right answer to that? 8. 8. I'm not going to go through it, okay, because that was a homework problem. So if you have any questions over that, I'll get this back to you, right? I'll get this back to you. Hey, when I say, or turn in, turn in. I already gave the answer out. Okay. All right, so if you didn't do well, I mean, this is why we take quizzes, to kind of let you know where you are with things, right? There's still time to make adjustments. You need to get tutoring, you need to get help, come to my office, go to the tutoring lab, get help. There's a famous quote that is from Albert Einstein. It's his definition of insanity. Have you all ever heard it before?
The definition of insanity is doing the same thing over and over again, but expecting the same different results.
Yeah, so it's, if you're getting, things aren't working out for you, right? And what you're doing isn't working, you got to change it, right? If you don't change it, the same thing's going to happen over and over, right? So we want to get to the point where we're comfortable. When's the most important day for us in this class going to be? Scheduled for the 28th of this month, which is how far away here? About 2.5 weeks from now. So that's when we take our first test, right? And that's going to be an important day. So the quizzes, look, if I could not give you quizzes, I would not give you quizzes, you know, because it's just more work for me. But it's to help you have an idea of the, you know, how much time, right, I expect you to be able to do that problem in. And, you know, just to keep you going on your homework, right? Can't force you to do it, but I guess I could, right? But I don't want to collect homework and grade, right? All right, we ready? Yes? Okay, we're going to move on. We're going to start. We are still officially 1 day behind on the schedule. That's all right. We are going to talk about functions today. And I feel like most of you probably have some experience with functions. Like you've seen functions in the past. So I'm not going to present them in a way that's like brand new. All right? We just want to get some certain aspects of functions defined. And then we're going to move and start doing things with them. So I don't expect you to look over there for everything here. I just want you to know that the ebook has these definitions that I'm about to start talking about. So we're going to talk about functions, but we want to start with this idea of what's called a relation. And a relation, according to the definition, is a correspondence between two sets. Set X is called the domain, set Y is called the range. In a relation, each element in the domain corresponds to at least one element in the range. Okay, what the hell are they talking about? So I want to do an example, all right? So let's say that we have, I'm just making these up on the fly. Let's say I have a list of people, okay? So I'm going to say like Jill, and then John, and then, I don't know, Bill, whatever. And then what I'm going to do is I'm going to create, this is the number of siblings that they have, right? So Jill would have a certain number of siblings, maybe 3. Maybe John has no siblings, and then maybe Bill has, 4, right? This is a correspondence between two sets of things, right? You have one set over here, which is called the domain. This is what? A list of names, right? People. And then over here you have the domain, the range, which is going to be just a list of numbers, right? And there is a correspondence from every element in the domain. There is a correspondence to something over here. All right, this is a relation. Let me give you another relation. Let's just talk about Jill over there. Okay, this is a totally separate problem. Okay, Jill, and let's say that Jill. We're going to list out 2020, 2021, 2022, 2023. Okay. So this is going to be a weird thing. Just watch. This is going to be number of cousins. All right? And this is going to be very strange, all right? Watch. So during 2020, Jill had one cousin. I'm going to make this up, all right? Jill had one cousin for part of the year, okay? And then like midway through the year, her aunt or whatever had another kid, so now she has 2, all right? So during the year of 2020, there was a point in time where she had just one cousin, and then she had 2 later on in the year, all right? Does that make sense to you? And then in 2021, let's say she didn't get any new cousins. In 2022, she didn't get any new cousins. Oops, sorry. That meant to go to the same place. Okay. And then let's say during 2023, she still had 2 cousins, but again, she had another uncle or something, had a kid, so now she has 3 cousins. All right, does that kind of make sense to you? It's a weird relation, but it just kind of keeps track of, during this year, this keeps track of how many cousins she had during that year. So she had 1, and then later on she had 2. And she had kept 2 for a while, and then it jumped to 3. Make sense? Okay, this is a relation too, because there is a correspondence between these sets. Yes?
So what is the difference between a function and an actual relation?
Exactly, so that's what we're getting to. What's the difference between a function and a relation, right? A relation is just any relationship between two sets of things, all right? Any relationship. I'm going to take the one that we just had here, put it down here, Jill. What was it, Jill? Bill? I don't remember. John, okay. And then I had said, whatever it was, who cares? 1, 2, 3. I'll just make it up. All right, so those were the 2 examples. That's a relation. What is a function? So I'm going to go and look at the definition of a function. Let x and y be 2 non-empty sets. A function from x into y is a relation, okay, which associates with each element of x exactly one element of y. All right, so when we go to function instead of relation, we have a very, very important restriction, and that is that when I start creating these relationships, every one of these elements in the domain can only go to one thing over here. That's it. It can only go to one thing. It can't go to 2 things. See this 2020? See how it goes to 2 different things? That's not a function then. This is a function because everything here goes to one thing, all right? So the key word in that definition is in this second part of it where it says exactly one element in y. So I'll give you a picture here. I'm not going to do any more like names and cousins. I'm just going to draw a picture. Let's say I have a function that takes these numbers. Let's say it takes 1/3. So far, is that a function?
Yes.
So far, yes? Okay, what about this?
That's not a function.
Yes.
Is it? What is the condition? That everything here goes to exactly one place. So does that go to exactly one place? Does that go to exactly one place? Does it say anything about they can't go to the same place. No, it just says that this has to go to one thing and one thing only. So the fact that they both go to 3 is still okay. It's still a function. And then 3, I can make 3 go to 10. It doesn't matter. This would still be a function, right? This goes to exactly one place, exactly one place, exactly one place. This is a function as well, right? This goes to exactly one place, this exactly one place, this exactly one place. One input, one output, all right? I'll draw one more picture here. Another example. Let's go 1, 2, 3. If 1 goes to 5, 2 goes to 5, and 3 goes to 7, and 3 goes to 5. Would that be a function? No, right? If you see it going to 2 places, it's over, right? Okay. Now, functions are what we study from here on out, right? When we go through pre-calculus and calculus, we are studying pretty much functions the whole time. In fact, when you get to calculus, we call the entire subject of calculus, Cal 1, Cal 2, Cal 3, we call it the calculus of functions of real variables. Functions of real variables. So we are only going to be dealing with functions, not relations, all right? All right, now, like I said, I feel like a lot of you have seen that before. So what I'd like to do is I'd like to put some algebraic equations up here and determine whether or not they are functions. So the question here is, are these equations functions? Question. All right, so let me give you your first example. Y equals x squared. Now here's the way I want you to look at this. Let's say we start here, we have a domain and we have a range. The domain here, I'm going to tell you right now, is x, okay? So these are the x's, okay? And the range are the y's. All right, so let's just try and plug some values of x in and see what happens. So what happens if I plug 2 in here? What happens to 2? 2 squared would be 4, right? So y would be 4. So 2 gets sent over to 4. Make sense? So far, is that a function? Yes? How about if I say plug in 0? Where does 0 go? 0 squared is still 0, so that's 0. So far, yes, still a function. How about negative 2? Where does negative 2 go? 4. Okay, is that still a function? Yes, right? This is a function. See, for every input I put here, you have to think about this. For every number I ever put here, I'm only going to ever get one answer, right? Now, it might be the same answer, like when I plug in negative 2 and 2, I get the same answer, but I'm not going to get 2 different things. Make sense? So notice here, and this is the subtle thing that students miss, all right, that the domain, right, the domain is the x's, and the range here was the y's, right? I chose that. I actually said that when I started the problem. I made that choice. It doesn't have to be that way. You can reverse it. You could have put the y's here and the x's here. And then if we do that, it changes things. Let me show you. What happens if I say, okay, let's try this again, but let's switch it. Here I want the y's, and here are the x's. So now, let me start by providing you a value for y, and then you provide me the x, okay? So let's start simple. What if y is 0? What does x have to be? So do y'all see it? If I let y be 0, if y is 0, then that equation becomes 0 equals x squared, and the only number you can square and get 0 would be 0, right? So if I let y be 0, x is 0. So far, is that a function? Yes? Now let's try 4. What if y is 4? You get 4 equals x squared. Uh-oh. What's wrong? There are 2 answers, right? 2 squared is 4, but negative 2 squared is also 4, isn't it? There are 2 different results here. Everyone see that? So if I try and plug in 4 for y, it goes to negative 2, and it goes to what? Positive 2. There are two possible things that x could be. And now it's no longer a function. Do y'all see that? So this should be strange to you because here we said it was a function, right? And here we're saying it's not a function. So which one is it? Well, you have to be specific. This right here, what we would say here in this scenario is we would say y is a function of x. Y is a function of x. It's like the y's depend on the x's. The x, you give me the x, right? And it goes to 1y. Y is a function of x. Here, we would say, what's on this side? The x's? We'd say x is not a function of y. So another way you could look at it is this. To say that y is a function of x means that if you give me x, there's only one y answer, right? You give me x, there's only one y answer that you can get for that x. Here, the other way around, if you give me y, is there one answer? No, there's more than one. So it's not a function of, x is not a function of y, but y is a function of x. Okay, do you all see the distinction between the two? When someone gives you an equation, they say, is that a function? You have to ask the question, do you mean a function of x or a function of y? Those are two different questions, all right? Okay, so how would we know here, how would we have known that it is this and it's not a function here? How would we have known algebraically? Let's try, do y'all agree that this is solved for y right now? Right, that's solved for y. Solved for y. So if I already said, if I plug in an x, I only get one answer. Take that equation and solve for x. Solve it for x. Let's see if we can do that. How would you get x by itself there? So I'm going to take this, I'm going to solve for x. Solve for x. So you said I'd do what on both sides? Square root. Okay. When you do the square root on both sides, when you initiate the square root on both sides of an equation, you must do plus or minus. Yeah. You must, all right? So I'm going to put the plus or minus on the y, like this. You only do it on one side. You don't need it on both. What's the square root of x squared? X. And now this is plus or minus square root of y. Is it solved for x? Yes? Can you see by looking at this that if I give you a y, right? If I give you a y, I'm going to have two answers, a plus and a minus, and that's no good, right? You plug in a y, you get two answers, plus and minus, except 0, right? 0, plug 0 in here, you just get 0. But any other number, we're going to get two different answers, right? So what I guess the big takeaway is this. If somebody asks you, are these equations functions, they have to be specific. Functions of x or functions of y, right? In your homework problems, every problem that you're given in the homework, they say here on the top, determine whether the equation defines y as a function of x. Y as a function of x. So they are asking you to basically solve the equations for y and see if it works. I'm not asking you, none of the home problems ask you to do this. So why am I showing it to you? Because when I see you in calculus, if you don't know the difference between the two, then you're going to run into trouble, right? You need to know now that there is a difference, all right? So let's do an example, another example. I'm going to go straight from the homework, and I'm going to start cranking some of these out. So the question is, are these equations functions? And I'm going to be specific here. Is y a function of x? Right? That's really what I mean. So how about this? Y equals x cubed. So can somebody tell me in layman's terms, raise your hand if you want to, tell me in layman's terms what you need to look at to determine if that y is a function of x?
If the y is squared, then that means there are equal points.
Okay, so if the y was squared, that would be a dead giveaway to you? Yes, what I'm asking is, what is your thought process here? Think about the picture. We're trying to say to ourselves, here are the x's, here are the y's, right? If somebody gives me an x, is there only going to be one y answer, right? So think about it. If I plug a number in here, right there for x, 2. 2 cubed? Is that just one answer? Yes? Is that going to work for every number you can think of? 0. 0 cubed? 0, right? See, there's no plus or minus here. We're never having to take a square root on both sides. See, y, we've already solved for it, right? So this is just, give me an x, there's only going to be one y answer. So yes, this is a function of x. Y is a function of x. Let's try one that's a little bit different. How about x plus y squared equals 1? Okay, now I have a little bit of a problem because it's not solved for y, is it? It's not y by itself. So I'm going to start by getting y by itself. And to get y by itself, I subtract x on both sides first, right? Just subtract x on both sides. Y'all agree? And now to get y by itself, I have to get rid of the square root, right? So to get rid of the square root, I take the square root of the left side. And because I took the square root, I have to do plus or minus. And that right there is like a dead giveaway, right? Because I had to do plus or minus, I know that y will be plus or minus square root of 1 minus x. And do you all see that if I plug in different values of x here, I'm going to get 2 separate answers, right? And that right there eliminates this as being a function of x. Yes?
Make whatever that answer is 0.
Then you would get 1, and that would work in one case, but any other number would mess it up, right? Well, not any other number. Some numbers you can't plug in, right? Because you get a negative under here. But like, plug in -3 for x. What would you get if you plug in -3 for x? 1 minus -3 is the same as 1 plus 3, which would be 4. What's square root of 4? 2 plus or minus 2, you get 2 answers. You see? If that happens one time, it's not a function of x. Okay, do y'all see? So we would say, no, it's not. Okay? All right, let me change that problem slightly. X plus y cubed equals 1. Is y a function of x here? Well, solve for y. Solve for y. Y cubed equals 1 minus x, right? And now, to get rid of the cubed, you do the cube root, right? Cube root. When you do a cube root, do you have to do plus or minus? No. When do you have to do plus or minus? When you do a square root or fourth root or any even root. Anytime you take an even root on both sides of an equation, you have to do plus or minus. Any odd root, any odd root, you do not have to do plus or minus. And so that means this left side is y and the right side is just the cube root of 1 minus x. And again, when I look at this, I don't have a plus or minus, or I'm not going to get 2 different answers. If you give me a number x, I'm only going to give you one answer. And that makes this a function. Is this making sense? Sure? Everyone? No questions? All right. Look at the problems 31 through 42. Somebody pick one for me and I'll do it. Which one do you want?
41.
The absolute value? That's a good one. All right, absolute value of y equals 2x minus plus 3. So this is one of your homework problems. The ones that are in yellow are your homework problems. Bless you. All right. So this is a little tricky because how do you solve for y here? There's an absolute value around it, right? Really, there's nothing you can do. It's not like this where you can do like take a cube root on both sides. You can't get rid of the absolute value. So what we can do is just try some numbers. Let's try some numbers. What we're trying to see is if we plug in x's, are we ever going to get something that goes to 2 different places, right? So let's just how about we pick 0 just to start with something clean, right? What happens if we plug in 0? What does this become? Let me write it down here. If we plug in 0, you get absolute value y equals what? 3. Can somebody tell me what y has to be for that to be true? 3 or negative 3, right? Plug in 3 for y. What would you get? 3. Absolute value of 3 is 3. And then if you plug in negative 3, you also get 3. Do you see that there's 2 different numbers that would work for this? That means when I plug 0 in for x, there's 2 different things that could come out. You see, for y. There's 2 different things that y could be here. And therefore, it is not a function of x. Yay or nay? Yay? Yes? No? Questions? Come on, this is your time. Okay, so what is it?
How would you get the -3?
Okay, so what we're saying is when we plug in x 0, right? When we replace x with 0, this goes away and we just get this equation right here, right? Which is that. And now I'm just asking you, what do you take the absolute value of to get 3? Right? So the absolute value of 3, of course, would be 3, right? But you could also have done the absolute value of negative 3 and also got 3. So there are 2 values of y that would satisfy this equation. And here they are. So when I plug in x is 0, there are 2 different y values that would satisfy the equation. And therefore, it fails to be a function of x, right? Okay, good, thank you. Any other questions? Yes?
Can you just write down a quick example of like a function or of y being a function of x that would work? Just like an equation that would, because I know like an absolute function exists, like the V shape.
Uh-huh.
Can you write down like an example of like one that would work?
That one that would work with an absolute value in it, or?
Yeah, with an absolute value. So like the absolute value of y is equal to whatever, like one that would, where y is a function of x.
I would have to do a domain restriction in order to make that work. I couldn't, because like you said, an absolute value is like a V.
Yeah.
Okay. Because of that, the only way around it is to restrict the domain to cut off part of the V.
Okay.
So there's no, but we aren't ready to talk about that sort of thing yet.
X is a function of y for that though. So if it was the absolute value of 2x, then it would be about y would be a value of x because
What are you saying?
we said if the absolute value was around the x instead of the y, it would be a function of x.
Would it be?
I think so.
That's a good. Let's talk about that. Let's do that problem. Is y a function of x here? Okay, so if I plug in a value for x, is it only going to go to one place for y? We'll start with 0, right? Plug in 0, what do you get here? 3. Okay, did that go to one place? Okay. What else do you want to plug in for x?
You can only go to one place. It becomes possible over there.
So 2, try 2, right? 2 in there, what would you get here? 7, right? Is that going to one place? How about negative 2? What happens if you plug negative 2 in here? It becomes positive 2, and then 2 times 2 is 4, and then plus 3 is 7. It goes to 7 as well, right? Is that okay?
Yes.
Yes, that is okay. Remember, we just can't have this go to 2 different places. Like here, went to 2 different places. It's okay if 2 different numbers go to one place. That's okay in terms of saying that y is a function of x. So this would be yes, all right? All right, now, let's move on, all right? Although this topic is important, it's not like the main reason we're doing this section, all right? So let's say I give you an equation, all right? I'm going to give you an equation now, and we're going to look at it, and we are all going to agree that yes, y is a function of x. So let's say you're given y equals, let's just take that example we just did, but let's just make it even easier without the absolute value around the x. Do you all agree with me that y is a function of x here? Meaning if you plug in an x, there's only one y that comes out, right? So y is a function of x? What would be a nice way for me to say that to you without having to write it down? Y is a function of x, right? What we do is we use a different notation. when we do have that y is a function of x, right? So I'm going to put here, so y is a function of x. We know that, right? We're going to use a different notation. What we're going to do is instead of writing down y, we're going to scrap the y, and we're going to write down this right here. And what that does is it makes you as the person looking at this not even have to think about whether or not it's a function. This is telling you that this side of the equation, right, depends completely on this one. And so if you were to draw this, your x's would never go to two places. By me writing this right here, I am guaranteeing that, all right? So y'all seen this before? Show of hands real quick. This is called functional notation, right? This is just means, it's telling you it's a function. So here, the way we say this, how do we say that right there? The left-hand side, how do we say that? F of x, right? F of x, right? We would say f of x equals 2x plus 3, right? That's the way we'd say that. Here, there are some important parts of this notation we need to understand. This f is actually the name of the function. Okay, that's the name of the function. So the name of this function is f. X, the thing that's being plugged in, right? This right here, the domain, that is called the independent variable. Because it's independent. When you think of independent, you're like on your own. You can do what you want, right? The independent variable is the thing you're plugging in, and that's kind of like free to be whatever you want it to be. The dependent variable is this side, okay? Is this number depends on where it came from, right? So that's your independent variable. All right, when we use this notation, what's nice about it is we can ask people to evaluate functions. So let's evaluate functions. All right, so let's go back to that. I'm going to give you that same function. Given the function f of x equals 2x plus 3, I want you first, part A, I want you to find, so how do I tell you I want you to plug in, let's say, the number 5. If I want to plug in 5 for x here, I would write f, and in parentheses I put 5, right? That's telling you to replace all your x's in that formula with 5, right? And so what would this be? Well, let's do it. F of 5 would be 2 times 5 plus 3.